About the new chapter, that is the diffraction of light. So this is the phenomenon of diffraction of light. uh, we are going to study about. So first we will start with the definition of the diffraction of light. So according to the definition of diffraction of light, so diffraction is a phenomenon of bending of light. So in this case you will observe the bending of light around the corner of an obstacle. So it's the bending of light around the corner of an obstacle, and you can say about an aperture into the region of geometrical shadow. Into the region of geometrical shadow of the obstacle is called the diffraction of light. You can see here it is a bending of light. So well, you can see with the help of the diagram. See, it is expected that as light travel in the straight line. So this is the source. In the first diagram you can see here, uh, this is the source, and as you know that light always travel in straight line. आपको पता है कि जो light जो हमेशा सीधी रेखा में चलती है, तो ये सोर्स है. हम एक्सपेक्ट करते हैं कि जो जो लाइट है वो एस टू ए प्राइम ही जाएगी, राइट. और या हम कहें कि एस से जो स्लिट के पॉइंट बी के ऊपर टकराने के बाद वो बी प्राइम तक जाएगी, राइट. But actually it is not so. Light will not only go from A to A prime, but it bend little bit in the region of geometrical shadow. So it will bend like this. So this is the diffraction. And here it will bend in toward this side in a region of geometrical shadow. This is the diffraction of light. So this is what we have to understand with the help of this definition. So once again, we have to go for the definition. This is a phenomena of bending of light around the corner of an obstacle. So see here, in this region you have seen, well, this is the phenomena of bending light around the corner of an obstacle here, and in this region. Okay, so here you can see that this is the diffraction region. So we can show it in a colored mode. This is the diffraction region in both ways. So this is all because of the diffraction that you can observe the light in the geometrical shadowstic region. Okay, so this is all because of the diffraction of light. So once again we can go for the definition. The phenomenon of bending of light around the corner of an obstacle. See here, light is going now from A to, and not only to A to A prime, but A to X. And here it is not only going from B to B prime, but it is going also covering the regions from A to bi also. So this is all because of the bending of light. Light can bend around the corners. So in another diagram you can see here, it is expected that the light will go, as it will start from this source, and it will go from S to A, and then A to A prime in a straight line. So S B B prime in a straight line, right. But it is expected that in reality, but it will not only go like this, it will bend around the corner. Now see here, it will bend in the region of geometrical shadow like this. It will also bend from here on, it will bend into the region of geometrical shadow like this. Okay, it will bend like this. So here it will bend like this. So this is the region of geometrical shadow. You can observe the presence of light. So with the help of colors you can see here, I'm talking about in this region. So well, you can see here, okay, this is the reason we can see. You will see the light in this region. So here on, you can see the presence of light in this region. Okay, I would like to color this now. So this is the region of geometrical shadow. It is all because of the diffraction of light, you have to understood, right? So this is as it's marked over here, this is the region of geometrical shadow. So further extending this discussion, that the diffraction of light is divided. This is the first one is the Fresnel diffraction, and second is the Fraunhofer diffraction. So Fresnel diffraction is in this type of diffraction. You can see in this figure, in the Fresnel diffraction, the figure number 1, you can see over here, in this type of diffraction, the source or screen or both at a finite distance from the obstacle or aperture. Now see here, he is talking about, this definition is talking about this distance. The source or screen, whether this is a source or this screen, both are at finite distance from one another, right? So this kind of diffraction is known as Fresnel class of diffraction, and in another case, in Fraunhofer class of diffraction. So this is a Fraunhofer. This is Fraunhofer diffraction. This is Fraunhofer diffraction in figure number 2. Okay. So in this type of diffraction, but we'll observe that in Fraunhofer diffraction, the source and the screen are at infinite distance from the obstacle or aperture. So इसमें जो source होगा वो infinite distance पर होगा aperture से और obstacle से, and it's causing the diffraction of light. And in this case, the light from the source at infinity, which is situated at infinity, after diffraction is focused on the screen with the help of this convex lens. So this convex lens is used to focus the light on the screen just at point O. Okay, so this phenomena of diffraction obtained on the screen is known as the Fraunhofer diffraction. So this is all about the diffraction, its definition, pictorial representation, and the different kind of diffraction we are going to study in this chapter, the Fresnel diffraction and the Fraunhofer diffraction. If you have any objection, confusion, chaos, then you can write in the comment box. Thank you.